It's been a while, but today I'm going to look into the summer revision package that I've been giving my students. So today we're going to focus on two things that students tend to get confused on, and that will be ammonia versus ammonium. And one of them is actually a gas, while the other is an ion. If you're still confused here, then follow me through on this. Okay, so this is a 14-mark question. If you have this package, this is question number 20. So let's get going. All right, so what's the main difference between ammonia versus ammonium? The formula will be written out here. Ammonia is NH3. This is essentially a pungent gas, really, really smelly. And ammonium here is referring to the ion NH4 plus. This is a positive ion, and in fact, this is one of the polyatomic ions that you really need to memorize. The other polyatomic ions would be this, like sulfate, nitrate, carbonate, which I'm not going to talk too much about it because there's one question focusing on this later. So with this question, we do need to draw a dot and cross diagram of ammonia, and they've given you the formula, so it should be quite easy. If you were to go to your periodic table, you will see that nitrogen has 7 electrons, which will be arranged in this order, 2, 5, and hydrogen, there's only 1 electron in its first and only shell, so that's 1 electron. So the rule about this is, for nitrogen, there's only 5 electrons in its valence shell. It needs 3 more electrons to be stable. So what you want to do is, if it need 3, then it will also share 3. So the rule of sharing covalent, the rule of sharing simple covalent is very simple. Whatever the number it needs, in this case nitrogen needs 3, it will also share the same number. So nitrogen, there's only 1 atom of nitrogen. I'm going to put it in the middle. And for hydrogen, you can see that from the formula there's 3 hydrogen. So 1, 2, 3. I should make this, yeah, okay. So for this sharing of 3, you can see that there are 3 overlapping spaces. Can you see this? These are the 3 overlapping spaces. So nitrogen will put 1, 2, 3. It's going to share 3, but in the beginning there's already 5. So 5 minus 3 electron that's being shared means that there are 2 electrons that is not shared, not bonded or not shared, and it will not be in the sharing zone, so it will be found over here. Okay, so that's nitrogen for us. And finally, for hydrogen, each of them there's only 1 electron, so they need 1 more to be stable. It will share as 1 and only 1. So there you go. That's the answer for drawing ammonia and H3. All right. So the next one here is complete the table by giving the missing information. 2 marks here. So first, you need to be able to identify what is the Cl. If you do use the periodic table, Cl on its own, it's actually chlorine, but once it is used to form an ionic compound, it becomes chloride. So things like this, chlorine becomes chloride. So ID at the back, bromine again becomes bromide. So it's very similar to oxygen as well. All the non-metal will go through this. Oxygen becomes oxide. So ID at the end. Okay. So next one is carbonate. In the beginning of the video, I mentioned the polyatomic ion, and carbonate is actually over here. So it's actually the CO3 with a charge of 2 minus. Now, ammonium is written as NH4 plus. So if you were to do a crisscross, what's going to happen here is I'm going to write down my ammonium and my carbonate first, CO3. So these things won't change. What is changing, or what is happening here, is you're going to just bring down the number in front of the charge. Okay, so it means there's 2 sets of ammonium, and because they are polyatomic ion, you will need to use brackets if there is more than 1 set of them. Okay, so the answer for ammonium carbonate would be this. All right, okay, so there we go. Next, we're looking at writing a chemical equation. I'm going to bring this down. Writing an equation for this reaction. So first thing is ammonia. Ammonia is written like this, and then reacting with sulfuric acid. Now, sulfuric acid is one of the common acid that you need to know. So the other common acid would be HCl, hydrochloric acid, and HNO3. So you do need to know their formulas: hydrochloric acid and nitric acid. Okay, and they form ammonium sulfate. So there we go. Ammonium sulfate is written like that. Did they write anything about ammonium sulfate? See? Yep, they have given you the formula of ammonium sulfate. So you do need to work backwards and recall sulfuric acid in this case. Okay, so that's 1 mark here because a lot of clues provided, so not much. There is no need for you to write state symbol as well. So there you go. Okay, next question here is on test of ammonium ion, and this is a 3-mark question. It is essentially three steps here. Okay, to test for ammonium ion, the first thing you need to add is actually our sodium hydroxide solution. Now this is a testing reagent that students tend to forget. Okay, next, after you add add the sodium hydroxide in, actually you won't see anything visibly. There'll be no color change or anything, but you need to heat the mixture. Now when you heat the mixture, you actually would get the smell, the pungent smell, and you want to test the gas evolved with a moist red litmus paper. Okay, why? Because the gas evolved in this case, this gas is actually ammonia gas, which is alkali in nature. So you will want to use red litmus paper, and this red litmus paper must be moist in order for the change to take place. Okay, so if the red litmus paper turn blue, ammonium ion is present. Essentially, this 3 and 4, step 3 and 4 is only 1 mark, so you do need to be mindful. After you use the red litmus paper, you need to tell us what's the color change or what's the observation change. Okay, so that's the 3 mark here. And then we have a very unique question, not always tested, but in this case, we are trying to test you on the percentage of nitrogen in ammonium nitrate, which is this one here. So if you look at the formula, you will see that there are 2 nitrogen, so over here and over here. So 2 nitrogen, and every nitrogen has a mass of 14, so you can use a periodic table. So 2 nitrogen means a mass of 28. So the percentage of nitrogen in ammonium nitrate will be 28 because there are 2 nitrogen atoms in there over the MR of ammonium nitrate as given to us over here in the question. So multiply by 100% and you will get 35%. So this is a very easy 2-mark question, only if you understand what you are looking out for. Okay, all right. So the next 4-mark question is a little bit tougher for a lot of students. Although fertilizers are not part of the syllabus statement, there are many information here in this table. So whenever you're given a table, there are essentially data that you can use and you must use to help you plan out your answers. Okay, so in the examiner report, the examiner always mentioned that for this kind of longer mark question, planning is essential for you to understand what to write. So first we need to understand the command word, and then we need to understand what's the keyword that we need to look out for. Okay, so here we are looking at fertilizer adds nitrogen to the soil to help plants grow. So we need nitrogen in the fertilizer to help the plant grow. That's one. And then they are saying that both ammonium nitrate can be used as fertilizers. There's nothing interesting here. We want to talk about the advantage and disadvantage, and we use the table which is above to help us answer. They give us a little bit of hint and clue here that the pH of rainwater is about 5.6. Okay, so I split my answer into essentially 2 columns, so you can see that. You can also write like that in exam, a table, and then you just put point form. Okay, so if I were to look at ammonia, what's so interesting about ammonia, which is the one in the first row, okay, is that ammonia, the pH is 11. So I'm using the title of the table to guide me in what to write. So I can discuss pH, I can discuss percentage of nitrogen, because they did mention, see, nitrogen is needed to help plant grow. So the more or the higher the percentage of nitrogen, the better this fertilizer is, isn't it? Okay. And the third one that a lot of students didn't pick up is actually the formula. And what exactly in the formula do we want you to pick up is actually the state symbol. Okay, so there are actually quite a lot of things that we can talk about, and it's worth 4 marks. Okay, so the first thing here is you want to talk about the pH. The pH is quite straightforward. For ammonia, it's 11, whereas for ammonium, they want you to talk about ammonium sulfate, which is this one, the third one. okay, is 5.5, which is very similar to rainwater, isn't it? Okay, so ammonium sulfate has a pH of 5.5, very similar to water, so it does not alter the pH of soil. But for ammonia, the pH value is 11, so it will cause the soil to be alkaline, and it's not good, right? Because if it's too acidic, when the soil is too acidic or too alkaline, swinging on the extreme part of the pH, it will actually damage the plant. Okay. Next thing I want to talk about here is the percentage of nitrogen, which is the second last column over here. Okay, so the higher the percentage of nitrogen, the better the fertilizer, isn't it? So for ammonia, it has a percentage of 82, whereas for ammonium sulfate, it has only 21% of nitrogen, so it's not as efficient as a fertilizer compared to ammonia, which is an NH3. This alone, yeah, has two main points really, or I would say, yeah, two main points really. Okay, and then next thing here, you can look at the state symbol. You see that ammonia is a gas, whereas ammonium sulfate here is a solid. And all ammonium salt, okay, when you learn this in final year, all ammonium salt, they are soluble, highly soluble. Okay, so you can easily dissolve them. So ammonium sulfate here, okay, it exists as a solid but can easily dissolve, allowing ease of use as fertilizer. For example, the soil can absorb this fertilizer easier, but ammonia, which is NH3, is actually a gas, so it's actually harder for the soil to absorb. So if you have presented this, there will actually be a total of 6 different points over already. The tougher one, unless you are a geography student or you read beyond the syllabus, okay, you might not know of the term eutrophication, which is basically too much nitrogen compound in water, leading to the overgrowth of algae. Okay, so this is the downside of using too much fertilizer. So they are both soluble in water essentially, but the downside of this is it will lead to eutrophication, it will leach into the soil. Okay, so this is the fourth point, but not easy to hit if you are not sure about this. But if you have talked about the main thing that is being presented in the table, you will have gotten a full 4 marks. Again, the hardest to score here would actually be looking at the formula. So everything in the table is essentially a clue. You do need to harness the small little clues, in this case the state symbol, to guide you in writing out the final form here. Okay, so this would be our 11-mark question on ammonia versus ammonium. Hopefully this has been helpful and get you started with your summer revision package. All right, see you on the other side.